ionic bonds. By ionic bonds, there's always one atom losing or gaining one of their valence electrons, so the electrons on the outermost shell. And there can be, for example, sodium. Sodium has 11 electrons, 2 on the first shell, 8 then on the second shell, and 1 on the third shell, and that one single valence electron can be given away, and now it becomes with a full octet on the second shell, and it becomes now sodium. And it is now a cation because it has too many protons. It has still these 11 protons, but only 10 electrons. No, it has one too much protons. It has now a charge of +1, because protons are +1, electrons -1. Another example would be the chlorine. Chlorine has 17, and chlorine could gain an electron, has been 18, and it has no electron too much, so it is too much minus. It is now -1, and now an anion. Cation is positive, and anion is negative. And they can come together and form then sodium chloride, for example, and then they have again a net zero charge. All ionic bonds as a compound form together, for example, sodium and chloride, as sodium chloride, they have a net zero charge. There can be such compounds with a plus or minus charge, but that are not ionic bonds but covalent bonds. And there are many of them in the human body, most of the times in solid forms in the human body. Ionic bonds as compounds are most of the times in the teeth and in the bones. Such thing like natrium chloride or sodium chloride can dissolve in water, dissociate in water, and when it is an electrolyte, because they are now plus and minus after again having dissociated again, and they can carry now an electric charge that makes them an electrolyte. And that is according to Gerard Tatoga and Sandra Gabrowski's Principles of Anatomy and Physiology book on the page 30 and 31.